Welcome to my 15th tutoring session in A-level chemistry. In this tutoring session, you will learn about modern periodic table of the elements. And due to the vastness of the topic, I'll be presenting the topic in a three-part series. Part 1 video is about the introduction to the periodic table. In the modern periodic table, you will find a total of 118 elements, of which 94 are naturally occurring on Earth, while the rest 24 elements are of synthetic origin. That is to say, these 24 elements, they are synthesized in the laboratory using nuclear reactions. The periodic table is a useful tool not only to organize the elements in a orderly fashion, but also it helps one to understand the properties of elements. Now, these 118 elements are arranged in the order of increasing atomic numbers as you move from left to right in 18 columns and top to bottom in 7 rows. Mendeleev organized elements by increasing atomic mass, while the modern periodic law arranges elements by increasing atomic number from hydrogen to oganesson. Periodic table is a table with 7 rows, 18 columns and 4 blocks. Elements in the periodic table are organized in columns called groups and rows called periods. Elements in the periodic table are organized in columns called groups. In column 1, you will find group 1 elements with 1 valence electron and oxidation number of +1. In column 2, you will find group 2 elements with 2 valence electrons and oxidation number of +2. In column 3, you will find group 3 elements with 3 valence electrons and with oxidation number of +3. Column 4, you will find group 4 elements with 4 valence electrons. And column 5, you will find group 5 elements with 5 valence electrons and with oxidation number of -3. In column 6, you will find group 6 elements with 6 valence electrons and oxidation number of -2. In column 7, you will find group 7 elements with 7 valence electrons and with oxidation number of -1. And in column 8, you will find group 8 elements with 8 valence electrons with oxidation number of 0. And elements in group 8, that's in column 8, they are noble gases with stable electronic configuration, and therefore they are chemically unreactive with oxidation number of 0. Elements in the periodic table are organized in rows called periods. Elements in row 1 have just only one electron shell and are called period 1 elements. Elements in row 2 have 2 electron shells and are called period 2 elements. Elements in row 3 have 3 electron shells and are called period 3 elements. Elements in row 4 have 4 electron shells and are called period 4 elements. Elements in row 5 have 5 electron shells and are called period 5 elements. Elements in row 6 have 6 electron shells, are called as period 6 elements, and elements in row 7 have 7 electron shells and are called as period 7 elements. Now, when you take a closer look at the periodic table, you will find elements organized in rows called periods. And the number of shells increase with the period number. Period 1 elements have 1 shell. Period 2 elements have 2 electron shells. Period 3 elements have 3 electron shells. Period 4 elements have 4 electron shells. Period 5 elements have 5 electron shells. Period 6 elements have 6 electron shells. And period 7 elements have 7 electron shells. And down the group, you can see as the number of shells increase, the size of the atom also increases. Elements in each period have the same number of shells. For example, in period 1, you find elements hydrogen and helium, and these two elements, they have only 1 electron shell because they belong to period 1. And period 2 elements like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, they have 2 electron shells. And reactivity of elements in each period depends on the nuclear charge. That is, reactivity of elements in each period depends on the number of protons they have. Now, this is a different topic altogether, and this will be the topic of discussion in my forthcoming videos. And the topic will be periodic trends in atomic size. So watch out for that video. Elements in the same period will have an increasing number of valence electrons. Let's consider period 2 elements. Now, lithium, it has 1 valence electron. Beryllium has 2 valence electrons. Boron has 3 valence electrons. Carbon has 4 valence electrons. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons. And fluorine has 7 valence electrons. So elements in the same period will have an increasing number of valence electrons as you move across a period from left to the right side of the periodic table. What is periodicity? Now, periodicity refers to the repeating trends across each row in the periodic table. Now, this is a topic of discussion in one of my forthcoming videos, the topic entitled periodic trends. So you can watch out for that video in future. Now let's take a closer look at the periodic table where the elements are organized in columns called groups. As per the IUPAC system, the groups are numbered from 1 to 18. So as per the IUPAC system of numbering, each group is assigned a number in increasing order from left to the right side of the periodic table. So totally there are 18 columns, that is 18 groups. Therefore, these groups are assigned number from 1 to 18. Now we'll be following the traditional numbering system using Roman numerals. So this is the traditional way of numbering the groups using Roman numerals. Now elements in each column have the same number of valence electrons. So in column 1, that is group 1, elements have only one valence electron in its outermost electron shell. And elements in second column, that is group 2 elements, they have two valence electrons in their outermost electronic shell. Group 3 elements have 3 valence electrons. Group 4 elements have 4 valence electrons. Group 5 elements have 5 valence electrons. Group 6 elements have 6 valence electrons. Group 7 elements have 7 valence electrons. And group 8 elements have 8 valence electrons in their outermost electronic shell. And elements in each column with same number of valence electrons will have similar chemical properties. So group number is equal to number of valence electrons. So group number 1 will have 1 valence electron. Group number 2, 2 valence electrons. Group number 3, or the elements belonging to group 3 will have 3 valence electrons, so on and so forth. Now I'd like to add a brief note about the grouping of similar elements. Now elements with similar chemical properties are placed in the same column or same group. Now these elements that are placed in the same column or group, they will have similar electronic configuration in their outermost shells, as I have just explained. And this leads to comparable chemical properties. So that is why elements in the same group tends to have similar chemical properties because of their similar electronic configuration in their outermost shells. For example, group 1 elements like lithium, sodium, potassium, they'll be having similar chemical properties because they have only one valence electron in their outermost shell. And in case of group 2 elements, they have 2 valence electrons. And group 2 elements like beryllium, magnesium, calcium, strontium, barium, they'll be having similar chemical behaviors, or they behave in a similar way because of their similar electronic configuration in their outermost shells. Because it is the valence electrons that is going to participate in the chemical reactions. And that is why elements in the same group have similar chemical properties. And what about the elements from group 3 to 12? You may ask me why I have not numbered it. Now these are transition elements with varying oxidation states or variable oxidation states. So let's ignore or avoid time being. And this topic relating to transition elements, that is group 3 to group 12 elements called transition elements, will be dealt in detail in part 3 of this video series, and you can watch out for that video. And this is how you number it using Roman numerals. Now the periodic table is divided to 4 blocks, that is S, P, D and F block elements in the modern periodic table. You will find the S block elements towards the left side of the periodic table, P block elements towards the right side of the periodic table, D block elements will be sandwiched between the S block and the P block elements, while the F block elements, you will find it below the S, P and D block elements. Now, how to organize the elements as S, P, D and F block, or how do you categorize them? How do you categorize the elements as S, P, D and F block? So let me explain. For example, let us take sodium. Sodium is a S block element. So you may ask me, how do I know that sodium is a S block element, or how do I come to a conclusion that sodium is a S block element? Now, in order to find out to which block the element belongs, you have to look into the electronic configuration of the particular element or the given element. Now, in case of, the element in question is sodium. Electronic configuration is sodium. Sodium is 1s2, 2s2, 2p6, 3s1. And when you observe the electronic configuration very closely, you will see that the orbital that is being filled with valence electron is s orbital. I have underlined it. So it is the s orbital that is being filled with valence electrons, and therefore sodium element belongs to the s block, or it is a s block element. So what about chlorine? To know about its to which block it belongs to, you have to check its electronic configuration. Electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. And which is the orbital that is being filled with valence electrons in case of chlorine? It is the p orbital, which I have underlined it. So in case of chlorine, it is the p orbital in the third shell that is being filled with valence electrons, and therefore chlorine is a p block element. What about iron? Let's check its electronic configuration. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. And here you will find that the orbital that is being filled is d orbital. So it is a d orbital that is being filled with valence electrons in case of iron, and therefore iron belongs to d block. Iron is a d block element. What about element europium? Now this is the condensed electronic configuration of europium. So its electronic configuration is very lengthy. So I use the condensed electronic configuration. So in case of europium element, you'll find that it is the f orbital that is being filled with valence electrons, and therefore element europium belongs to f block. So to summarize, s block elements have their valence electrons in s orbitals. P block elements have their valence electrons in p orbitals. D block elements have their valence electrons in d orbitals, while f block elements have their valence electrons in f orbitals. So this is how you organize or categorize S, P, D and F block elements, depending on the electronic configuration and the type of orbital that is being filled with valence electrons. Now let's take a closer look at the periodic table, considering both the columns and rows. To summarize, the periodic table, or in the periodic table, elements are organized in 18 columns called groups and 7 rows called periods. Now period 1 elements have 1 electron shell. Period 2 elements have 2 electron shells. Period 3 elements have 3 electron shells. Period 4 elements have 4 electron shells. Period 5 elements have 5 electron shells. Period 6 elements have 6 electron shells. And Period 7 elements have 7 electron shells. So as you go down the group, with increase in number of shells, the size of the atom increases. Now across a period, as you go from left to right of the periodic table, you will find the 18 groups, and as per the IPA system, the groups are numbered using English numerals. So totally there are 18 columns, that is 18 groups, therefore assigned with 18 English numerals in increasing order. So we prefer the traditional numbering system using Roman numerals. Now group 1 elements have 1 valence electron. Group 2 elements have 2 valence electrons, the outermost shell. Group 3 elements have 3 valence electrons in their outermost shell. Group 4 elements 4 valence electrons. Group 5 elements 5 valence electrons. Group 6 elements 6 valence electrons. Group 7 elements with 7 valence electrons, and group 8 elements with total of 8 valence electrons in their outermost shell. Now the group 8 elements, also called as noble gases, have a stable electronic configuration with their outermost shell completely filled with 8 valence electrons. So group number will be same as the number of valence electrons. So group number 1 will have 1 valence electrons, group number 2 2 valence electrons, so on and so forth. Now in the periodic table, each element is assigned a box, and within the box you will find the details of the element. Like in case of chlorine element, you will find the name of the element, symbol of the element, its atomic number, and its relative atomic mass. Don't forget to subscribe my channel, share and like my videos. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting video, which is continuation on the topic periodic table.